Yeah, they're vectors, and they're all pointing in one direction, I guess, to the right. Coriolis vectors.
Make sure you do the right-hand rule with your right hand.
Yeah.
'Cause, I've heard people messing up and doing it the other way. We're live, so whenever we want to go, we can go.
All right. I think we'll get started.
Yeah. Bruins in 7, Dr. Martin.
Who are they
Bruins in
playing?
7. Oh, the Maple Leafs.
See, I want the core 4 to be, or core 6 to be in the, as far as they can get. No, they'll beat them. Okay, welcome to our weather discussion. We have today and then 2 more, and that's it. And then you have to go look at weather maps on your own all winter, summer long. Imagine that. That'll be difficult, probably. Other things, but because the weather is so boring in the warm season, let's face it, it's just, it is. Isn't it boring?
Unless there's a duration.
I know, soon there'll be hurricanes, 5 of them or something, and we'll get all excited about 5 storms. Yeah, well, that's true, there's wildfires, and they got an early start this year, didn't they, because it's been dry in some places and warm, so fuels are drying out. So it's not boring entirely, but it's nothing like, strong baroclinic zones and strong dynamics, so that's all I mean by that. Now that I've avoided alienating everyone in the room, but not quite everybody. Let's take a look at our last week's satellite. Pretty interesting week. We had last Friday, I think we're getting back to the beginning here. Pete, can we just go back to the beginning?
Yeah.
Yeah, a week ago Friday, a week ago today, I mean, we had this disturbance off the Pacific coast. It was kind of sliding south, but I showed you a cross-section through there. We had 2 PVU air down to like 750 millibars or 800 millibars off the coast. And that feature was kind of getting itself ready to spread some precipitation over the California coast. And I turned it over to Patrick, and I was thinking, maybe there's something in the forecast for Tuesday or Wednesday, and or Monday and Tuesday. And Patrick said, no, it looks like Tuesday and Wednesday, and we watched that go. Watch on the satellite picture in the reality how this actually goes. So that'll be the first thing we look at here as a recap. So here's that upper disturbance, very intense upper front on the back side of it, and then it kind of crashes into the California coast. Then it seems to disappear. This was something we kind of saw. This is the subtropical plume coming up. There's the upper disturbance, and then it all gets itself back together for our extreme rain on Tuesday night into Wednesday, or Monday night into Tuesday, I forget now. So that was just exactly as forecast. In the old days, those features that kind of cut off down near the Southern California coast were kind of lost in the forecast models for a period of time. They're lost in the satellite picture, which is really interesting. You don't see any more obvious manifest period, but Monday and Tuesday, most of the places that were under the gun saw something. I won't go on a whole recap. I don't actually know much about the tornadic activity that may have occurred on Monday and Tuesday. If somebody does, I'm happy to be informed. But I know that the severe weather broadly was in 2 big splotches, one in the western plains and then one that moved closer to us on Tuesday. And it was right on target, so it was really interesting. And you can see it blow up in the satellite. And then and a beautiful circulation center stayed over us, gave us rain into Wednesday because it was just cold aloft and the stability was low. This thing was kind of this extra little drizzle for yesterday morning. And I was driving to Black Earth trying to charge up a battery in my 1999 VW, and I tried to turn it over when I went home yesterday. It doesn't even turn over now. I got to get a whole new battery. Yeah, so it's a disaster. But anyway, I had a nice tour of the driftless area in the light rain, trying to charge the battery up. So we had a big storm that came through by Wednesday, pretty much over by Thursday, and we'll see some of the remnants of the structures that still reside. One of them just to our north, which you can see it now. It's going to have an impact on us over the weekend. Maybe the last cold air spillage of the season over Central and North America. That's what I think, and I think there's reason to believe that when we go into the other thing that's very cool about this infrared can't miss it. And Pete, we're going to have to stop this a couple of times.
Sorry, the live stream is.
I know,
video
he's
is not
doing
working.
lots of stuff. I know he always is. Can we back up a couple of images? Keep going. Right there is a really good one. So we're nearly, what time we? Yeah, we're in early afternoon or late morning. It's warming up nicely along the coast. Look at the Gulf Stream edge. You can see it's got a bunch of little waves in it, eddies and so on. And if we animate forward, you can kind of watch some of them now that you've seen them. They don't move because they just don't evolve over the timescales that these weather systems on top of them do. But you can sure see the Gulf Stream edge. A couple of really beautiful, a cold pool there, a little warm eddy down to the south. Really nice, isn't it? How you can see that? And so, and you can also, if you're interested, you can watch the Great Lakes not change color during the day while the land around them does. Watch that. Everything's gray in the morning, only the lake stayed gray in the sunshine in the afternoon, so that's kind of cool. You know, this radiation stuff's really true. You should make sure that you pay attention to the environment, right? It really is true. Don't take that stuff for granted. Don't take that stuff for granted, and don't just blow it off like somebody made it up. It's really true. Okay, so I guess that's all I had to say about our animation for the week. A couple of things I wanted to highlight. So can we go now to our, maybe our current short-term loop, so we're not distracted by all the other things we're
You
doing.
want the colored one?
Yeah, thanks.
Sorry.
I don't know what this newfangled stuff is all about. No, this is great. So, beautiful morning here today, absolutely crystal clear skies. You know, today's the 249th anniversary of the Battle of Lexington Concord. So this is when the revolution started, April 19th. Next year will be 250 years. Amazing, isn't it? And made observations every day. He was at a house on the Lexington Green, and on this day, the temperature was 45.7, winds from the west, brilliant clear skies, beautiful weather, fair weather. So it's exactly like 249 years ago. And we beat those guys pretty badly back then, as it turns out. And that was the beginning of the end for them. But here's this little clear swath that gives us our nice morning, but boy, you can see these stratocumulus filling in, even on the southern edge of what's now a well-established deck. You can see them filling in the several hours after the sunrise over the Dakotas and central and southern Minnesota, and then the northern part of our own state. So daytime heating is really potent as a cloud producer at this time of year, because we still have invasions of relatively cold air aloft. You'll see that when we go to the 500 millibar map. And that cold air pool, as I was mentioning earlier, is maybe the last really substantial one for us. Maybe not other parts of North America, but it might be the last one for us, because we don't see one even in the 10-day forecast, which gets us almost to May 1. And boy, it's hard to have another one of them after May 1st. It's not unprecedented, but it's rare. So we'll see. Broadly speaking, across the country, beautiful clear skies off the Pacific coast. That's got to mean, I'm going to guess, big ridge over the Pacific Northwest at 500 millibars, and offshore flow. You can see the Cascades littered with snow. Even the Olympic Range has snow on them right there. Look at that. Mount Olympus has snow on it. Isn't that awesome? Crystal clear over there. Beautiful day in late April in the Pacific Northwest. And then a collection of really interesting disturbances over the Atlantic all week long. So there's this really intriguing little comma-shaped feature that, you know, it's kind of dead. What is this? Where did it come from? Is interesting. More large-scale synoptic type disturbances are much more obvious further to the east, and those are partly related to what we had here on Wednesday, but not entirely the same storm. So that's the broad picture. I don't think our clear skies will last very much longer, actually. We're actually seeing some of the stratocumulus, daytime fair weather cumulus coming in, and I think once they come in for real, I guess the clouds will be the rule for the rest of the day and probably tomorrow. Okay, one other thing that's neat about these maps at this time of year is, look at how this gets white over Lake Okeechobee and central part of the peninsula. That's all extremely small scale fair weather cumulus spots. They just populate quickly from the daytime heating. The sea breeze helps on both sides of the peninsula, but it also occurs, as you can see, in southern Georgia and parts of the rest of the south. I'm not sure this isn't cirrus obscuration entirely, but this one definitely is not. But this looks the same, and so I think it might have some of the same origins as what we're seeing there over the peninsula. So that's kind of cool. Let's go to the 500 millibar map, Pete. So here's 500 millibars this morning at 7 a.m. Look at how cold this is. It's minus 32 at International Falls. That's pretty darn cold for the late part of April, right? I mean, that's downright chilly. And the front edge of that comes right across southern Minnesota, southern South Dakota, and so on. So you can see that's about where you get to about minus 27. That's the minus 25 isotherm right there. So it must be that surface temperatures, I'm going to guess what they have to be. I'm going to guess we have to have a lapse rate of about 7 or 8 degrees over these places. So if it's minus 27 at Minot, It's got to be at 5 kilometers, it's got to be about +8, +10, 50 degrees there at the surface, and that's enough to produce moist, unstable lapse rate, and you get some clouds developing there, so we'll check that in a minute. But it's pretty chilly, even -31 in the analysis over southern parts of Montana. So that's pretty chilly. You have to go all the way up to the archipelago to find -30. So this is isolated and chilly. Where exactly it goes is going to have something to say about our weather over the weekend. But it does seem almost impossible to imagine that temperatures at least as cold as -25 at 500 millibars don't sag over us during the day tomorrow. And that, I think, means there's no way we escape the clouds, because the stability will just be perfect for producing clouds. And there's a lot of water on the ground, and there's a lot under the ground to be evaporated, so it's easy to imagine close to 100% relative humidities, or at least reasonably well moistened air. So that's a problem for our weather. Broad scale across the country, westerly flow. And that means everywhere east of the Rockies is going to be warmer than it usually is by substance. And that'd probably be especially true over the Central Plains, Kansas, Nebraska, parts of eastern Colorado, the Panhandle of Texas. We'll see when we go to 850 whether or not that seems to be bearing out in the observation. Before we leave here, though, what an incredibly wavy time of year this is. And maybe this underlies some of the stuff that we've been recently finding in Libya. It's just hard to find long segments of jet streaks because there's so much perturbation to it. But look at this, a cutoff low here, big anticyclone over western Canada, cutoff over the archipelago, cutoff over us, ridge over the Maritimes, another cutoff south of Greenland. So it's very, very wavy everywhere north of about 38 degrees or 40 degrees. So, Andrea, you have a comment on that from what's going on with the stratosphere? This is the dying days of the stratospheric polar vortex?
Yeah, we did have a recovery, so it wasn't, the last SSW wasn't the final warning. So
Oh,
we had
okay.
a recovery, and this is actually
The
the timing
denouement-
of the final warning.
The denouement is upon us.
Yeah.
So, and this is about climatological, right? Near the
Yeah.
20th or so of April?
Right,
Okay. So nothing particularly unusual about this end to the stratospheric vortex, but I've always wondered, is that period of time particularly wavy? This is a small segment of the northern hemisphere. It's only a fraction of the western hemisphere. So pretty wild. And I think my sense is, and it's anecdotal, that that's been the case for a large part of the spring thus far. We've had a lot of waviness over North America and adjacent waters. And I have a measurement of the 300 millibar streamline of maximum circulation. I just haven't referred to that. I should probably prepare that for next week. I'll do that. Okay, so that's what it looks like at 500 millibars. While we're in the middle and upper troposphere, let's go to 300 feet just to see what the jet structure looks like. And we're in the transition right now that Libby's identified in her work, that we seem to lose one or the other of the jets. Maybe this is indicative of, how can one imagine a subtropical jet with all of these little jetlets at high latitude? So very much like what we had last week, but further south over the coast of California, we have this intense jet on the western side of what's a pretty intense upper trough. That was displaced here last week and led to some of the severe weather in the middle part of the week for us. And then here we've got this jet right at the base of that strong baroclinic zone, we saw at 500 millibars. And it's got a little appendage at 300 millibars over Oklahoma and Kansas, I bet at a higher level. That's the predominant jet. And then this is a feature on the eastern side of the feature south of Greenland. And then another northwesterly jet over the western archipelago. Let's go to 200 millibars, Pete, and see whether or not that's true. Yeah, it's not really dramatic. The northern jet feature weakens. It's no longer in the 130 knot range, so we were seeing the core of the polar jet down over Iowa in the prior map, and now we're looking at the top, the hood of the polar jet. And then this is a little bit more intense of the subtropical jet. We're at 200 millibars, right? I don't think we'll see anything better at 150. Well, why don't we give it a try? No, how about 250? No, how do you like that? So that's it. I mean, it's a weaker subtropical jet there, and there's little pieces that are weak in the 70 to 80 knot range to the south. So this part of the hemisphere is dominated by polar jet streams, not the subtropical ones. How interesting. Okay, so, Larissa had that comment, didn't she? That maybe the subtropical jet goes into hibernation because the ITCZ gets weaker in the southern hemisphere. Interesting. Okay, now let's go to the lower troposphere, closer to where we live. How about 850? So here's our giant cyclone over in northern Ontario. And pretty decent cold advection. You don't probably need to know that because it's gotten so much colder over the last couple of days. This morning was, I think, 40 degrees at my house, pretty chilly. And still, pretty decent cold advection. Winds aren't weak either, 30, 40 knots. I think some of the gustiness that we're feeling outside today is a function of mixing in the vertical, because these winds are a lot stronger than the pressure gradient would suggest they should be near the ground. We have a weaker pressure gradient force at the ground, but pretty strong winds just a mile above. And with the daytime heating as it was with no clouds at all for the first few hours of the sunlight, I think it was easy to mix that high momentum down. There were a couple of gusts on the way over and back from class that just took my breath away. It was pretty amazing. Now, Alex and I got caught in one right around the education building.
Oh, yeah.
Nearly blew us over. Well, I'm speaking for myself. He's a young, stout young man, so maybe it's different for me. And then there's a bit of a thermal ridge. We saw that in the surface temperatures. I didn't show you this, but we did it in class today. This is a beautiful example of a cold, warm, and potentially occluded frontal structure in this region. And this is the thermal ridge at 850 all the way up into southeastern Ontario. And temperature was 57 in Pittsburgh this morning, and colder to the west and colder to the east. So it was right in that little narrow wedge of warm air. Okay, so that's interesting. That's our storm. I'm going to leave it to Patrick to tell us about the forecast, but I'll say a couple of things about aspects of that. First of all, we may be at the limit of the lower tropospheric cold advection. You got to go way up to the archipelago to get much colder air. And it is much colder. It's minus 36 at 850, way up in the archipelago. But we might have exhausted our cold advection pretty much by the end of the day today for this first round. But I don't know that that's the case at other levels. But this is the only thing that had me wondering what's going to happen next for us. And I think this thing does make a close approach in the near term. So we'll say something about that. One other comment. Alex and I had a conversation about this, and it's kind of bubbling up on the internet. The notion that their record rains in Dubai, they had a month's worth of precipitation, or maybe a season's worth in a day or something.
A year and a half's worth.
Oh, a year and a half in one day?
Yeah, it's like 5 inches.
So it's outrageous.
Yeah.
There seems to be some rumors cropping up that this was a function of cloud seeding. And the fact is, cloud seeding doesn't work on anything like that scale. And there's been a long, tortured history about this, starting in the 40s, 50s, and 60s with climax experiments and so on in Colorado in the late part of that era. One of my best friends, Art Rango, was a research scientist for a long time at Durango. And he became suspicious that this stuff was being overstated. And then he went to the University of Washington and worked in Peter Hobbs' cloud physics group. He wrote tons of papers, some of them with Hobbs and some of them without. And the ones without were without Hobbs because he was a little bit afraid that Art was getting a little too angry at some of the cloud seeding people. One of them was Professor Goggin at Jerusalem, the University of Jerusalem. And he had spent a whole career building up cloud seeding experiments and results, publishing these results. And Art went over there and said, can I get a peek at some of your data? No. Can I get a peek at some of your analysis methods? No. So Art funded his own research, including an aircraft flight over the Mediterranean. And long story short, ended up showing that Goggin had really been involved in some bad stuff. And that some of the rules that he had said were applicable to cloud seeding success in the Eastern Mediterranean were completely bogus. So here we are again, looking at cloud seeding in the Eastern Mediterranean, proposedly, and I think that it's equally bogus. And one of my graduate student colleagues, Bob Dietz, who's now a professor at the University of Wyoming, he's a cloud physicist, and he spent a lot of time developing cloud models, and his contention is they're at the level of sophistication now that you can actually test. The essential problem with cloud seeding is, how do you know that by perturbing this cloud in this environment, it rained only because of your perturbation? You don't know that it wouldn't have otherwise. But with a model, you might be able, a sophisticated enough model, you might be able to make that statement. And it turns out Bot's gotten his cloud model to the point where he's pretty confident that that's true. You can actually use the model output to say, had there been this perturbation of one kind or another to seed the cloud, it would have delivered more precipitation. So he's come to the conclusion that cloud seeding can work, but without commercial application. So it doesn't do enough change to the cloud to make it turn what won't precipitate at all into a deluge, which makes me really suspicious of these rumors that have cropped up about Dubai being, an inadvertent example of some mad scientist gone crazy with cloud seeding. I don't think that's true.
It sounded like the Dubai precip was in the models a couple days ahead of time.
That's right. That's the other thing that Sarah had mentioned to me.
The operational models don't have cloud seeding.
That's right.
Yeah.
Intensity and temperatures.
There were signals of it.
You're right, and they don't have
cloud
cloud seeding plans in the model formulation. Of course, that'll only spur the really adherence to the conspiracy theory to say, well, that means that everybody's in on it.
We're all part of the cover.
Yeah, so how do you get out of that? But it seems to me that's not the case. And it doesn't make it less interesting. It's still a really interesting case. You'd sure like to know what happened there, but it's not cloud seeding. So let's get that off the table and stop thinking like scientists and not conspiracy theories instead.
I've heard
That'd be my
before from
suggestion.
cloud physicists that it's easier to actually prevent the cloud from precipitating than actually moving it.
Oh, is that right?
Yeah.
That's really interesting. Okay, that's really interesting. So I like that. Okay, so that's all I have. I wanted to bring
Do
that.
you want to
into
look at the surface
conversation.
temperatures in Nebraska?
Oh,
Or
yeah,
just
yeah,
at
yeah,
50 or
yeah.
so?
Let's just see. We should be in the low 50s or so.
Of course, this is a little close. This is going to be a little bit later than what you were looking at.
Big Canada. 53, 56, 50, that's exactly what you need. It's minus 27 about here at 500, so this is like plus 10, plus 12. Temperature difference of 39-ish degrees over 5 kilometers. Oh, son of a gun, that's an 8-degree lapse rate. That's that's unstable to moist processes. So it's conditionally unstable. And if it's moist enough, you're gonna get clouds developing. So that's nice, kind of really nice, works. So not only does this radiation stuff carry water, but so does this thermodynamic stuff. So those of you who are studying all this stuff, we're not fooling you, we're telling you the truth. That's all I have. Patrick, thanks.
While we're on
It's
this,
7:45.
snow in the Dakotas, this is a 21-degree dew point depression,
Oh, yeah.
and it's snowing. Interesting. Could we start with the...
It's not isolated either, there's something.
Yeah,
Yeah.
that's the power of
Very
sublimation
dry.
right there.
Yeah.
Can
Could we start with, I'll tell you the website. It's usanpn.org. So I'm going to start with the National Phenology Network because spring has come here, and I know that because of my allergies. The weather's going to be boring, so I'm going to take some time and look at this spring status here. So they actually make really cool maps, and I know I've shown this before. I think this is the one. Yeah, so this is a tracker of spring, essentially. It's when the wooded plants leaf out, and this is an animation. We're in February right now. Anywhere it's red, spring is happening earlier than usual. So we were record warm. Essentially, most of the northern part of the United States was record warm, and because of that, we are having a record, well, not record, but a very early spring. More than 20 days earlier than normal, and I'll let this loop again. And then the only other place that this is also happening is in the Valley of California, which is interesting. We'll see that on another map as well, but
That's good, we're gonna eat all those plants.
right, exactly, yeah. These are the fun plants. Here. The fruits. Yeah. Could we exit out of this? There's one more map. I think it's in here. And maybe if we scroll down. Yeah, here we go. And I remember I showed this map a while back. So this is a map of how normal this spring is to recent decades. Everywhere it's green, this happens early, spring is happening early, and it's a frequency of how often this occurs. So it starts out every 1 to 4 years, spring is this early in all the places where it's this like putrid yellow green. Everywhere it's dark green. This is the earliest spring on record. And I remember I showed this map because we were watching spring creep up, creep up, creep up. It stopped here last time I showed it. And I was thinking, great, we're going to have our earliest spring on record, set some records. Interestingly enough, this is pretty normal for us. This happens every 5 to 10 years that spring comes this early. So despite all the warmth, and it is an early spring, this is pretty frequent for this part of the country. And then you can notice, again, in California, for some reason I do not know, maybe because of how wet it's been, spring came early
Yeah, I wonder if
there.
that isn't it. Yeah, that's
Yeah.
probably it. And then I got a question that maybe you don't know, Patrick, but first of all, you keep on, every time you suggest the URL, I know it's gonna be interesting. I mean, that's the cool thing about it. But the other thing, what about markets, grain markets? Do they react to this?
Yes.
Probably.
And I was gonna ask you, Andre, I figured you probably know that.
Yeah, they have a lot of people who do like agricultural hedging.
Yeah.
So they look at this and they say, okay, maybe they'll be able to get 2 crops worth of things if it's in early spring.
Yeah.
So that they can, once they harvest, they can reuse.
Is that soybeans in particular they can do that with? I don't know if they can with corn, I don't know about that.
Yeah, I
it
don't
takes
know.
so long to
Yeah,
grow.
not corn.
Wow, that's interesting. So
Yeah.
they might be flying high, but they might be in for a surprise,
Right.
as always.
Yeah, and then the other question is, well, what is the likelihood of a freeze event
Yes.
with such an
yeah.
early spring?
Yes.
So should we actually take advantage of the early spring?
Right.
Because our crops are really, you know,
Oh, man, what
cold
an interesting
sensitive.
problem,
So
yeah.
that's like one of those things where it's like, okay, well, let's look at the 3-week forecast and really
Yeah.
understand the likelihood of a cold event.
Oh, very interesting, yeah.
The other thing I was going to mention is that this is a big cicada season.
Yeah.
So with this, I mean, it's probably going to happen soon.
Oh, yeah,
Probably.
right.
There are maps.
Oh, yeah.
And then I got a question about that. Do they screech only above a certain temperature?
Yeah, I think it's when the ground reaches a certain temperature, the soil temperature, then they emerge.
Okay.
So, I mean, I would have said they would have emerged early. And I think parts of Illinois and Indiana are like in this region where the 17-year cicadas are emerging, but so are a subset of 13. So it's going to be like a super
Yeah,
cicada season.
Chicago, that region.
Yeah.
What decibels do they reach?
I don't know that, but
Yeah.
yeah, so.
And I'm interested in if we'll hear them earlier. You know, once they're mature and they're making sounds, I wonder if they come out earlier. Do they still need a certain activation temperature to stop making their sounds? I don't know about that. Wow,
Because we
interesting.
exit out of this, funny enough that you bring that up. I haven't looked at this, so let's see if this is good.
webpage.
Can we scroll up?
Probably knows where it
Cicada
is.
mapping.
And keep going. Click here.
Sure knows where it is.
Forecast of pests and invasive species. Let's see what these are. I haven't looked at this.
I'm okay.
I think if we scroll down, maybe.
Buffalo grass, current day forecast.
So this is not a pretty map, unfortunately.
Hmm.
Winter moth. I don't see cicadas on here.
No.
So maybe they're not technically invasive.
Maybe they're not considered invasive.
Yeah.
Or damaging, maybe they're.
Interesting. But if we could scroll up, I just want to see what this is. Emerald ash borer. Okay, so this is the emerald ash borer adult forecast, which I'm not sure what that means, but
But here it is.
Oh, that's so cool.
But look at the valley. The valley is next week. You gotta watch out
Oh,
for.
yeah. Oh, okay, maybe it's when they're reaching peak
Yeah, when they
growth or something.
Yeah.
So it's already happened in the south and it's going to happen here. Interesting. And it's not happening because there's snow still.
The valley and the bite are both in the same category in all of these things.
Yeah.
It's really interesting.
Okay. Next site, can we go to the drought monitor, please? Because this one first. Hope I see it. So we've gotten plenty of rain. We haven't been in a drought, so let's see if that will be reflected in the drought monitor, but we'll see how the rest part of the country is doing also here. So first, we could just stay on this. Here's a look at the current drought monitor for the country. Portions just to our north and west have seemingly been in a drought for a year at this point. When the whole state was in a drought, we were pretty bad with all the fires and everything in the summer. We recovered. I'm not sure why areas just to our north are not recovering. They've stayed this way for months. Same with Iowa, has been in the drought for a while. So even though these places are having their earliest spring, you still need rain to grow your crops. To keep the prices down of growing your crops, I should say. So, areas in Illinois and Indiana where it's so moist and it's been an early spring, crop is probably going very well there. Here you're having to spend more money to grow your crops. Much of the southeast, which had been in a drought for a while, is not in a drought. And California is seemingly, has been the drought bullseye for the last decade. Almost no drought in the entire state. Actually, yellow is just abnormally dry, so it doesn't count for the drought. You need to be in this, sand color for it to actually be a drought. We can look at the forecast, though.
I wonder what the sweet spot is for an early spring. You probably don't want it to be wet when you're plowing, but you'd like
Correct.
it to be wet as soon as you seed it. I wonder if the earliness can be perfectly phased and if they've passed it or not. That's kind of an interesting operational question of which I know nothing.
What does the S and the L and the SL mean?
Oh, yeah, good question. Those are indicators of how the impacts are going to be. So S means short-term impacts, L means long-term impacts. Everywhere it's outlined means this has been a drought for a while, and you're going to see these impacts. So this is saying there's short-term and long-term effects, long-term effects. Where it's lasted a while, you're seeing long-term effects, and if we scroll down, there are,
Nobody has just an answer.
keep going here. Yeah, so they all mean different for different places in the country. And we can actually click on the Midwest, we could, like our region, and you'll see, I think if we scroll down on this map, so here's just a zoom in of, oh, okay, I think we actually have to click on something. So let's click on like Iowa, please. And if we scroll down, it tells you exactly what you see in these categories under this table here. If we keep going down here, so it'll list for Iowa, corn is, dry when it's abnormally dry, and then you can see some pond levels decrease, less mosquitoes. That's a nice thing, not for the ecosystem, but for us. And so it lists out the different things you expect for those categories.
So this must be a market influencer on every day too, right?
Oh, yeah.
Has to be.
Somebody's looking at this every day,
Has to be.
especially over Iowa, Nebraska. Wow.
Yeah. So, interesting, you can spend a lot of time on this website.
I like category D2, fewer mosquitoes.
Yeah, exactly. Okay, so now we can do our normal forecast. And I'll make this relatively short because the weather's going to be boring here. It's going to be nice, it's going to be sunny, but there's not going to be a lot happening over much of the country. So if we can start at 500, and we'll just go 12 hours, and then I'll step 24 hours in the forecast. So here's that feature, that trough, that's bringing us the clouds. You can kind of see, you can use this vorticity edge as sort of the edge of the cold air advection at 500. So it's made its way over us by tonight at 6 p.m. You can see not much else is happening over the country. This is that storm that was spinning off the east coast. I don't really know how it got there, and it's kind of been an anomaly. When I've looked at stuff of how it's persisting, maybe it's just so warm. Not connected to anything, so it's just probably going to fizzle out. You can see in response to, we have the massive ridge over the western portions of the United States into Canada, and then a massive trough on its backside. Maybe some, precipitation due to this strong vorticity gradient. We could take a look at that, but aside from that, when you have these big rings of vorticity with not really an end, you don't really see impactful weather because there's no gradient. But little short waves, you can see how wavy the flow is, as we've talked about as well. Areas, south of Nebraska, though, are completely devoid of really large-scale features, it looks like, to me. We'll see if we go to the surface map at this time, please. Take a look at that. And so here's that, temperature gradient that's moved over us. You can see the cold air advection. Winds go counterclockwise around this low, and they're advecting that thickness gradient to our south. Anywhere where the lines intersect, perpendicular, that's cold air advection happening over much of the center part of the United States. We might be on the back edge of it, and the coldest thicknesses are just centered over International Falls, it looks like, for the United States. But other than that, and this band of precipitation along the cold edge, there's not really anything happening over the entire CONUS, it seems. Not anything synoptic scale, I should say. Not anything organized. And you can see the wavy patterns, very strong temperature gradient up in Canada, where it's still cold, and then some precipitation right where we saw that vorticity gradient and this low and trough feature just south of Alaska as well. So let's step 24 hours now. And we'll just take a look at this pattern, not really do much over the eastern, or over the CONUS. So this trough eventually makes its way into British Columbia and then into Washington. Definitely precipitation forced by that, we'll see that. Over much of the country though, nothing. This storm exits, this trough feature exits. Looks like Sunday, Saturday evening, we're still in that cold, really cold temperatures. We'll see that at the surface, but here's that vorticity strip that was sort of the proxy for where the really cold air is. Uninterrupted flow over all of Canada, straight south, and going right into our region.
Right
So-
from the pole.
Right. So this is why it's cold. It's flow straight from the poles, where that's the only place it's going to stay cold. And we can see that at the surface at the same time. Yeah, so here's, you can see the temperature gradient associated with that flow. Cold thicknesses have made its way almost all the way to the Gulf, where they're interacting with, the moisture and the warmth over the Gulf Coast. But over us, perfectly clear, we're under high pressure for Saturday. So even though it'll be cold, it'll be sunny, which is a trade-off. Definitely, you can see interesting feature of cold thicknesses beginning to make its way south. I don't think this will impact us. We can take a look at that. If we just go 24 hours.
Can we see
at the
850 though
surface.
first?
Oh, yeah.
Just to see what the
Yeah,
temperatures
yeah.
are like there?
Good call. It's about 36.
Ooh,
Yeah,
cold.
so this is why it's cold. I mean, it's cold everywhere, but
Yeah.
we're having flow straight from Canada.
You see how isolated that is?
Yeah.
That's really the only red spot in the whole
Right.
map, so that might be the last one.
I hope so.
Me too.
I mean, everyone hopes so. You can see in response to that ridge, the warming that's happening.
Wow,
over
all the
western
way to
Canada.
the north coast of Canada.
Right there, so might be time for vacation. up
Yeah.
Wherever this is.
Somebody went to Churchill for April and they're regretting it because it's
Right.
probably -10 or something.
Right. Yeah, I can't even imagine people live there.
Yeah.
And it seems like it stays this cold at 850 on the surface for months.
It does, yeah, you're right. That's an
Nice.
epicenter of cold air
Yeah.
in the northern hemisphere in the winter.
I'm sure you get used to it, but I don't know. It doesn't sound fun to just always be cold every single day. And let's go ahead, 24 hours. We'll just do the surface. I want to point out something though at the end, which we'll see. So this is now Sunday evening. We're still under high pressure, so it'll still be sunny. You can see really lack of anything organized over the CONUS. Here's that lobe of cold air. It's beginning to make its way into the country, but it seems like it's going to miss us. If we just take this edge, this thickness line is the edge of that cold air. We're still going to be cold, it's just not under the influence of that lobe of cold air. Doesn't seem like it's going to impact us at this moment. And rainy as the cold air is sagging slowly and slowly down towards the Gulf Coast and interacting with all the moisture and the warmth still down there. But this high pressure is dominating, a majority of the country. And in response, we don't have any large-scale precipitation forecast. Let's skip ahead 24 hours at the surface, please. This will bring us to Monday evening. Now we might have a chance for some precipitation. There's a trough feature that's going to move over and force cyclogenesis. We can see that represented by the sea level pressure, and then not too much of a temperature, perturbation with it. Seems like it's beginning to form some sort of cold and warm front. You can take a look at that too. But this lobe of cold air misses us completely and impacts northern Maine, where not a lot of people live, which is nice, and then moves off and produces a pretty intense disturbance right north of Maine. Here's Maine. So you can imagine still winter, still pretty heavy snow for that system. And then here's a nice development, 970, just off of Alaska as well. But over our region, besides this, not much happening. Let's go 24 hours from here. Here we look. Here we're now at Tuesday evening. We're still in the influence of that cyclone. Maybe some light precipitation on its backside. We're definitely into colder thicknesses again. And you can see winds go counterclockwise around this low, and they're advecting those colder thicknesses to the south. You can see the edge of that cold air making its way almost exactly what's happening now, just shifted towards the east. And we might be in some precipitation for a while, although light. And then high pressure on its backside as well. If we go 24 hours from this, So now we're into Wednesday evening. We're out of the cyclone impacts. We're still under the colder thicknesses and high pressure. So essentially what's happening today, it'll be chilly, but it'll be sunny come Wednesday evening. And then we get into another potentially warm up with these warmer thicknesses and this thickness ridge extending all the way into central Canada, central western Canada, I should say. And then my last figure I'm going to show, if we go 24 hours from this, and I'll end on here. What seemingly has happened for a couple weeks in a row now, there's a 15% chance of severe weather over Oklahoma, Nebraska, and Kansas. And that seems to be a recurring feature for the couple of weeks. There's been just a bullseye over this region, and it's under the impacts of this low pressure, which you can imagine if it's impacting areas to our west is eventually going to impact us, Thursday being Friday. But interesting that it keeps happening over the same region week after week after week, and they keep hinting at severe weather over almost the exact same cities. And we could take, actually, if we go to the weather.gov page.
What does 500 milliamps look like at this time?
Oh, yeah.
Everybody just see the general direction of the flow.
Yeah, sure.
That was 156.
Yeah, that's right.
Oh,
Yeah, so a
that's
very
not what I
small feature,
Yeah.
not really coherent vortex.
And not really a clear stream from the plateau, but maybe it's
No.
maybe it's a day downstream from that. So maybe the day
Could be.
earlier you could have had flow off the Mexican plateau.
That's
Because
right.
that might be what drives the recurrence of this, is that there's a passage of waves over northern Mexico, puts the elevated mix layer out over the warm moist boundary layer, and
Right.
then it goes off.
Right. For sure, I have no doubt that that's what's happening. It's just interesting that it keeps happening over that region. So we're almost out of time. Is there anything anybody else has comments on or wants to see? It's going to be nice weather for us, 50s, 60s, sunny, chilly in the morning. It'll feel like fall because it'll be dry, but
Yeah.
I haven't really had a lot of moisture yet. So.
All right, thanks, Patrick.
Yeah,
Thank you,
thank you.
Pete.